All right, so here we have particle x that's moving along the positive y-axis, and its position for positive values of t is given by this equation. So part A is asking, is the particle x moving left or toward the right at time t equals 1? Okay, so to answer this, we have to first recognize that velocity is going to describe how an object is moving, like in what direction and how fast, its speed. So since this is position, we take the derivative of position because velocity is the derivative of the position function. So we can label it, we can say v of t is equal to x prime of t. And for that we'll get 15t squared minus 18t. And if we want to figure out what's going on with the velocity at time t equals 1, we just plug 1 into here. So we calculate x prime of 1. And for that, we'll get 15 minus 18, which is negative 3. And we'll get that it's moving to the left because the velocity is negative. Okay, so now at what time for t greater than or equal to 0 is particle x farthest to the left? Justify your answer. All right, so this essentially is going to involve us figuring out when the particle changes position. So we want to see, when it's going to the left and when it changes to the right, and if it goes back to the left and back to the right. Once we know when it's changing position, we look at the intervals for when it's going when it's going to the left, and then we just basically take the endpoint, because the longer it's going to the left, the farther to the left it's going to end up being. So let's just first solve for the zeros of the derivative. So let's always do the work up here, just so you can see it easier. So we get x prime of t is equal to 0, so we set this equal to 0. So we're going to factor out a 3t with a 5t minus 6. And so for this, we'll get t equals 0, and then 5t minus 6 equals 0, so t equals 6/5. So we want to see what's going on from 0 to 6/5, and then from 6/5 and beyond. Now, we already figured out what's going on at t equals 1 with velocity. We know it's going left. So in here we can write x prime of t is negative because 1 is in this interval. So we know it's moving to the left. Now it's possible it could keep moving to the left after 6/5, but let's just double check. So we're going to just evaluate this for some number. We'll evaluate it for t equals 2 in there. So we'll take x prime of 2, see what we get. So we'll get 15 times 4 minus 18 times 2, so minus 36. With 60 minus 36, we get 24. And that's positive. So that means it's moving to the right. So that means that it's going to be the farthest to the left from where it started at 6/5, because that's when it has the most time to travel all the way to travel left. It's traveling to the left from 0 to 6/5, so obviously it's going to be farthest to the left at 6/5. part C. All right, another particle, y, is moving along the positive y-axis, so its position is given by this function, y of t is equal to 7t plus 3. At any time t is greater than or equal to 0, the origin and the positions of the particles x and t are the vertices of a triangle in the first quadrant. Find the rate of change of the area of the triangle at time t equals 1. Okay, so this may sound a little more confusing than it is, but once you think about it, it's actually pretty simple. So let's just draw a little picture. So we know one of the vertices is, at 0, 0. So we don't actually need to have a picture of what this triangle is looking like how its shape is changing, because we have 3 variables. So to do this, really, you want three-dimensional geometry, where we have t, x, and y. So think of it like this. So in a triangle, the area of a triangle is equal to 1/2 base times height. And so if we think of x as the horizontal distance as the base, then we can simply plug the x function for the base, and we think of y as the height, because again these are the other vertices. Then that'll represent the height in this formula. We can plug in the y of t function for this, and then that'll give us the area. So let's put area is equal to 1/2 x of t times y of t. Now, if we want to know how the area is changing, the rate of change of the area, we're going to take the derivative of this. Take the derivative of this and then plug in 1, and we can see what's going on with the area at that time t equals 1. So let's go ahead, let's just write down this as a function. So we're going to have one-half x of t. Let's just write down 5t squared minus 9t, 5t cubed. Minus 9t squared plus 7, and 7t plus 3. Now evaluating this, we're going to have to, it's going to be pretty tedious. Let's just be careful that we don't mess up. 1/2. Multiplying all these by 7t first. 35 t to the 4th minus 63t cubed plus 49t. We multiply all these by 3 plus 15t cubed minus 27t squared plus 21. Let's just combine any like terms in here. So it really looks like we'll combine thirds and the, so we get 35t to the 4th, 63, so minus 48t cubed minus 27t squared plus 49t plus 21. Now let's just take the derivative of this. So then we'll call it a prime of t. Keep that 1/2 as our coefficient because it's just going to be 1/2 times the derivative of this. So 4 times 35, 7140t cubed. It's 3 times 48, so minus 1, 44t squared minus 54t plus 49. And then we just plug in 1 into here to figure out what's going on. T equals 1. So it's a prime of 1 gives me 1/2. 140 minus 144 minus 54 plus 49. 1/2, so that'll give us -4, -58, so -9. And our answer will be -4.5. And there you go. That's all there is to it.